supported by industry investment, by environmental regulation, and increasingly by customer choice within major markets. So when we look back at the development of xEV sales, we can see that the transition was very much started by the shift to hybridized vehicles in the mid-2000s through to, say, the mid-2010s. And during this period, the Toyota Prius was the main vehicle of choice and led the way in hybrid vehicle sales. And it wasn't really until the mid-2010s, with the acceleration of sales in Tesla models in the European and US markets, combined with sales of Chinese domestic brands such as Geely, Great Wall, BYD, that battery electric vehicles, BEVs, started to gain notable market share within the passenger vehicle market. And this is really shown clearly by that chart on the bottom left here. For commercial vehicles, the transition happened much more suddenly, as the initial upfront costs of battery electric vehicles were seen as a significant barrier to sales of these vehicles within larger delivery or transport fleets. Now that we are seeing greater kind of cost parity between ICE vehicles and hybrid and battery electric vehicles, and also the lower overall operating cost for battery electric vehicles in particular, we've seen a sharp uptick in plug-in hybrids and battery electric vehicles in these commercial applications in particular. When we look more closely at the regional split for xEV sales globally and how this has really changed since 2018, we see the major automotive markets dominating sales, with Africa really forming only a very minor part of the global markets, forming one of those lines along the x-axis that you can see along there. In 2020, African sales represented less than 1% of global xEV sales in particular. So it's still a very kind of fresh market within Africa. Now, the challenges that many African countries face in terms of customer purchasing power are largely to blame for this, but also with a lack of supporting legislation for electric vehicles, high import taxes, and a lack of the supporting infrastructure which goes along with electric vehicles and making them comfortable products for consumers to use. Now, as EVs become more affordable and comparative to ICE vehicles, however, markets, including Africa, are expected to see a strong uptake of xEV models, despite the lack of maybe rigid emissions regulation or standards that we see in maybe some of the other major markets, like in Europe. And it's the forecast expectations for electric vehicles globally are quite eye-watering over the coming decade. Sales volumes are expected to approach 35.2 million units by 2031. That's compared to, say, 9.5 million units in 2021, representing a compound aggregate growth rate of around 18.7%. And one of the factors to really look at in this is that a greater proportion of those vehicles are going to be full battery electric vehicles rather than hybridized versions. Now, this is expected to totally reshape the automotive industry, as the development of ICE models are scheduled to be discontinued at many major automotive manufacturers during the 2020s and 2030s. Despite this ICE vehicles, or despite the kind of transition to more xEV models, ICE vehicle sales will continue to form the majority of vehicle sales globally through to 2031. though really the writing is on the wall for ICE sales in increasingly stringent emission standards being in place in a wider number of jurisdictions also. The market share for xEVs is expected to approach 43% by 2031, and again with battery electric vehicles in particular, so those with those larger batteries requiring more raw materials, forming 22% of that total volume. Now, strong growth is also expected in other xEV models and fuel cell vehicles in particular, though hydrogen technology is not expected to take off in passenger vehicles for several reasons. And these include the availability of infrastructure, the sustainability of hydrogen generation, and also the cost of infrastructure installments as well. Now, it needs to be said that the automotive sector forms only one part of the rechargeable battery sector. And as this chart on the right here shows, it has become the dominant sector within the market, but it needs to be considered that there are other applications for portable electronics, power motive devices, and energy storage systems as well, which form very significant parts of the market overall. The automotive sector has been the largest industry sector since 2017, however, and this is only expected to increase over the period to 2030 and 2031, continuing to build to around 82% of total capacity by 2030. Now, overall battery capacity in lithium-ion technologies is forecast to increase at a significant rate of 23.6% per year in the period to 2030, sorry, reaching 2.46 terawatt hours of battery capacity. Now, in comparison, this is roughly equivalent to 3.5 times the reported operational lithium-ion battery production capacity globally in 2020. As I mentioned, those other applications, portable electronics, continue to form an important end use for the market, with growing uses in, say, wearable technologies, 5G technologies within mobile phones and laptops, etc. Though volumes are really overshadowed by the larger cells that are being incorporated into automotive ESS and some motive applications as well. For motive applications, the increased use of e-bikes, e-scooters are driving that demand, though there continues to be competition from nickel metal hydride and lead acid batteries in particular. Now, the increase in automotive applications that we've seen over recent years and what we're expecting to see over the forecast period has resulted in a significant shift in the types of raw materials which are used in the production of these battery technologies, in particular when it comes to the cathode and cathode precursor materials. So for the cathode outlook, we've really seen a transition towards high nickel tertiary or cathode materials, pretty much NCM and NCA type cathode materials. And this chart really shows how we're expecting that cathode split to develop over the coming years. Now, there's been a large number of announcements by major automotive manufacturers, by Tesla, by VW, now by Daimler as well, who are transitioning to a very kind of split mix of cathode materials, which is going to have a notable impact on raw material demand. Now, the one big shift that we are seeing is the shift towards LFP cathode materials in particular. So that's those that don't require nickel or cobalt within their cathode mix, but are still a huge demand for lithium. So by 2030, we're expecting to see LFP cathode materials form 41% of the total cathode volumes that are being produced, though in terms of the battery capacity, which is included within that volume, it's expected to represent only around a quarter of that capacity. And that's to do with the lower energy density that LFP cathode materials have compared to the ternary cathode materials like NCM or high nickel cathode materials in particular. When we're looking at the raw material requirements, which are caused by this shift, I mentioned that nickel and cobalt are not required within the production of LFP cathode materials, but it also changes the types of lithium compounds that are able to be used. For high nickel cathode materials, for those which have a very high energy density and are expected to still be used in luxury and performance type vehicles, you need lithium hydroxide really as your feedstock for use in that. Whereas for LFP, it's much more amenable to lithium carbonate usage as well. So it starts to cause a change in the raw material requirements that are seen there. When we look at next generation battery materials as well, or battery technologies, the onset of solid state battery technologies could likely see increased use of lithium metal. We're now seeing announcements by, say, CATL looking at sodium-ion technologies as well, which could again see a shift away from maybe lithium to sodium technologies in lower intensity use or end use requirements, needing lower battery capacities. When we look at where this the production of lithium-ion batteries is expected to take place. At Roskill, we have our internal gigafactories model where we track all of the announced factories which are in the pipeline. And we're expecting to see really the Asian market continues to have a strong hold over that battery production. Europe has seen a lot of investment in the development of battery production capacity, particularly over the past 18 months. And we see Europe forming that second largest production center for battery products. When we have a look at other regions, particularly Africa in particular, there is very limited investment or very limited commitments which have been put into developing battery capacity within the African continent. And this is something which could change, but will likely need to see incentives to promote the build out of battery capacity on the continent. And that really brings me on to the kind of final points that I want to talk about is really what are the opportunities for Africa when we're looking at new energy applications, and particularly for battery and electric vehicles. It's clear to say that there is great potential for African nations, though the competition from other strong economies, particularly in Asia and in Europe, has made it difficult for African countries to attract not only the investment, but also the technical backing of major OEMs in the battery and in the EV space. As I mentioned in the previous slide, there has been very little commitments from lithium-ion battery producers to date in locating manufacturing capacity within Africa. And this presents some issues for the automotive industry in the region in particular. ICE vehicle manufacturing presents a major source of employment, of tax revenue, of exports for multiple African nations, but South Africa in particular. And as OEMs continue to transition away from ICEs and really major markets transition away from the sales of ICEs, governments and markets will need to create attractive opportunities for OEMs to invest in the construction of battery electric vehicle manufacturing capacity within their jurisdictions, whether that being through the construction of new facilities or retrofitting existing manufacturing facilities for ICEs and retraining staff to be able to undertake the construction of these new technologies. Now, in terms of how the supply chain for batteries and EV technologies is expected to look in the coming years, the technical knowledge centers in Asia, Europe, in North America, where the majority of commercial scale lithium-ion battery manufacturing is expected to take place, are also likely to become major distribution centers for assembly plants in Africa or regions without that domestic major manufacturing capacity for xEVs. Now, this is a similar setup to the current process for batteries used in ICE vehicles, whereby, say, lead acid or lithium-ion batteries are imported for the use in assembly within, say, the South African market. Now, to develop the electric vehicle market in Africa, there needs to be a continued support from the infrastructure build-out, particularly for charging infrastructure within the major markets, particularly South Africa. Now, whilst this has started, it remains relatively sparse, particularly outside of major urban centres or main transport routes within the country. Now, other subsidiaries to bring down the cost of electric vehicles would also boost electric vehicle sales, though these tax breaks and subsidies will only be able to support that demand for so long, as has been seen really in China and in other regions. And it really needs to be that self-supporting market that needs to be developed to look at the longer term success of the electric vehicle market within Africa. Now, Africa's main advantage in the supply chain for electric vehicles and battery materials is the diversity of raw materials that's used in lithium-ion battery technologies, and the potential to extract these minerals and metals to support the growing demand for lithium, for cobalt, for nickel, manganese, and in graphite. Now, the abundance of natural resources within Africa is clear, with these diagrams here showing in blue the nations with existing production capabilities of key battery raw materials and also refined production there. For lithium, those countries highlighted in blue represent countries or in the lighter blue, represent countries with projects under development for lithium production across Africa, from AVZ Minerals in the DRC to Iron Ridge in Ghana and Mali Lithium in Mali. Now, whilst lithium mineral production is developing, there is little to no processing capability in operational or under development within Africa, however. And as developers look to limit the initial development risk and the capital requirements which are needed for project development, this has been one of the kind of barriers to improving the value add. As we see the acquisition of stakes in Mali Lithium by major lithium refiner Ganfeng Lithium in June, and also Ganfeng's involvement with AVZ in the Congo, it shows how the supply chain exposure for African operations is being limited by those off-takers as they look to maintain and grow their market share in higher growth markets such as China. For cobalt, the situation is slightly different, with much greater refining or production of intermediates taking place within Africa. Now, this is strongly supported by those government regulation, however, and it's unclear if a similar approach would be successful in other raw material markets, such as, say, lithium or graphite, to ensure that greater value add was being achieved in country prior to export. Now, Africa does provide the potential to grow with the lithium-ion battery industry, which needs significant additional capacity to stop raw material availability being a restricting factor on growth. Now, the two charts here show the distribution of African production of key battery materials on the left-hand side here, mainly for those used in anode and cathode technologies, along with the chart on the right-hand side here, which shows the the distribution of mineral reserves in 2020 globally. Now for cobalt and manganese, which are already very mature within the continent, it shows that African production is far exceeding its proportion of global reserves, as might be expected with really the concentration of world-class and top-tier operations located on the continent. ESG factors, however, may start to erode some of the market share for downstream customers in say, Europe and in North America, however, with a particular impact on cobalt production in the DRC, though overall the robust demand from Chinese operations is expected to support production volumes in particular. For lithium, the proportion of global supply remains below that of the distribution of mineral reserves, though further development of operations is expected to see African production outperform its reserve distribution in the coming years. And similarly for graphite, that's forecast to see African production become much more predominant, and production really that's seen as Chinese production continues to be disrupted by challenges over ESG factors and regulations imposed by the Chinese government, and African supply is expected to take over some of that production. Now, it's not only the battery materials which are expected to be impacted by really the growth in electric vehicles in particular. The rare earths market, and particularly the use of rare earth permanent magnets within motor technologies, is also expected to see significant growth. And Africa has a lot of potential for rare earth production, with numerous primary rare earth operations being under development, really listed here. You can see there's a large concentration within East Africa along the Rift Valley, and also in Namibia and South Africa. But it's also the number of heavy mineral sand operations which could be looked at as well. There's monazite production from Rio Tinto, from Kenmar, from Tronox, which are all looking at rare earth production as a byproduct of titanium and zircon mineral sands. And this really represents a large opportunity for byproduct production of these rare earth products without significant capacity requirements to bring a lot of that capacity online. Now that is going to look at the mined production of rare earths. The refined production still is expected to be very much centered within the Chinese market, although other opportunities which are expected to be looking for raw material sources are becoming more available, and Africa certainly has great opportunity to be a raw material source for rare earths. Well, now, thank you for listening through that presentation. We'll now open up the panel discussion with my colleagues Igor and Dominic here. I'm really happy to answer any questions that you have on any of the topics covered, or if there are any further questions outside of the scope that you'd like to rack our brains on.
Thank you very much, David. Some fascinating numbers there and some fascinating technologies. I'll open the floor to questions and discussion. Would anybody like to just unmute yourself and jump in? Maybe I can start with a general question concerning the philosophy of these vehicles. I mean, looking at the presentation and the various news feeds that we received during the course of our working day, it looks to me like currently, in terms of vehicle technologies, we've got 5 to 6 different ones out there. And in terms of battery technologies, there's probably 10 to 15. Are we going to see a reduction in numbers of technologies? You know, for example, will hydrogen fuel cell technology eventually lose out to lithium-ion technology? That sort of thing. Are we liable to see that in the next 10 years or so?
It's difficult to kind of say longer term, where where technologies like hydrogen will really fit in. There are applications or kind of scenarios where hydrogen fuel technologies are very beneficial compared to, say, typical lithium-ion technologies, or even maybe next generation lithium battery technologies such as solid state. But really what we see is that there's been a huge investment in lithium-ion technology. It's been factored into the designs or model designs for the major OEMs over the coming 10-year outlook. And this is expected to really remain the scenario over the coming 10-year period. There are some competitive technologies which are expected to take some applications. As I mentioned, sodium ion has great potential for maybe ESS applications, or those where a lower energy density is not quite as vital and raw material costs are much more important. But certainly the lithium-ion technologies are really here to stay now for at least the next decade or so. When it comes to the variations in lithium-ion technologies, I had that slide which really looked at the different cathode materials which are being looked at. This continues to be quite a dynamic market. There are the development of new technologies, particularly a shift towards high nickel cathode materials for performance vehicles. That will continue to be the case, and we'll see that transition over the coming decade or so. It is now starting to become much more diversified in where advances are being seen within the battery component technology. So there's a much greater focus now on anode technologies, whether that be increased use of silicon within graphite anodes, or whether it be a shift towards lithium metal anodes in particular. There continues to be this transition as technological advances are made. But in terms of how this is going to be used in say, the automotive market, these technologies need to be able to be produced on a commercial scale. They need to be well tested. They need to be incorporated into model design, and then that model needs to be produced as well. So within the kind of 10-year outlook that we're really focused on at Roskill, lithium-ion batteries are very much the dominant technology. I'm not sure if Igor's got anything to add on that.
No, I think you've covered everything.
Great.
We have a couple of queries in the chat box, and one of them is, how does the lithium-ion battery compare with the VRBs?
I can take this if you're okay, David.
Yeah, go for it.
Yeah, well, generally, vanadium batteries are forecasted to be a niche application in the energy storage systems because of their fascinating cycle life, but the energy density is very low compared to lithium-ion batteries. So using that advantage as the cycle life would be very critical for energy storage applications. And yeah, there is still a question about the material availability as well. But I think that in certain circumstances, when there's a demand for higher demand for energy storage applications, I think that market eventually will come to new business models, as we've seen recently, like electrolyte leasing, and yeah, come with our other financial instruments to support the material availability as well.
I think maybe one point also to touch on is that it doesn't need to be a kind of one or the other technology. There's multiple situations where lithium-ion and vanadium redox are used in conjunction with each other. I know in the UK there's an ESS station which is using both of these as a kind of a combination technology, and I think that we'll start to see an increasing amount of a combination of these technologies being able to then draw on the advantages of both technologies outweighing just using one kind of dominant technology overall.
We have another question in the chat box concerning electricity generation and the distribution capacity of various countries where we need to recharge these vehicles, and particularly on the African continent, you've got large different distances between centers. How do you see the support structure evolving?
Yes, I mean the energy generation, I suppose, in South Africa is one that I'm sure many of you are familiar with, but certainly the incorporation of more energy storage capacity, either that being on a personal basis with using, say, electric vehicles or household energy storage systems, will likely have some advantageous effects on load leveling. Which can really assist with kind of reducing peak powers and peak power surges and the kind of requirements on the grid. So there are certainly some advantages there that could be for the, say, South African grid. It's important to remember that these the electric vehicles and the systems which are used to charge these vehicles are relatively communicative products. They are smart and they can adapt their charging time and the speed of that dependent on the grid usage and what is really being seen. So it's unlikely that there will be that huge kind of surge on demand or creating issues there. I think one issue that really could be seen, however, is the kind of small grid scale infrastructure that might need to have, which would likely need upgrading as it is in kind of all regions again. So there are some potential disruptions that could that could be caused by that, particularly the energy demand on a household to household basis. But overall, when it actually comes to kind of national energy generation, it's unlikely to cause many issues. Igor or Dom, I'm not sure if you've got any more to add on that.
No, I think that was a really good answer, Dave. Just to kind of sort of add on a little bit, when it comes to, and correct me if I'm wrong here, but in terms of EV uptake, this typically occurs obviously in the cities primarily, and then it kind of fans out over a much longer time frame. And I think it's important to note that sort of 7 out of 10 of the world's fastest growing economies are in Africa at the moment. And so when it comes to developing power infrastructure, while there may be sort of bottlenecks here and there, overall, I think it wouldn't be unfair to say that the countries can manage it.
Okay. There's another question in the chat box from Michael Cronwright. How do you see the South African auto industry driving the African case for EVs? In other words, South Africa has a pretty well-established auto manufacturing capability. Will they be able to change fast enough or completely enough to be competitive, to remain competitive? How do you see that playing out? Stunned silence.
Sorry, I thought Igor was going to speak.
I'm gathering my thoughts. Sorry. Yeah, well, basically, I think that South African economy has pledged to carbon neutrality at 2050, if I remember correctly. So at some point, I think that the regulations would eventually force producers to switch to electric vehicles or other kind of zero emission ones. as through the probably higher taxes for internal combustion vehicles, or the credit system that we've seen in China, for example. But usually this kind of change is starting within the government support, as David mentioned in the presentation. But I would say that these changes would probably start with the government level, and well, eventually producers would be smoothly transitioned to electric vehicle generation production, I think.
I think there's probably a point to talk about how the ICE market, or how the automotive market, and particularly in South Africa, is set up at the moment as a predominantly exporting kind of industry. As we see those major markets like Europe and the US really cutting out the sales of ICE vehicles in a 10-year period, it's going to remove significant market or export market for African or South African manufacturers of automotive. So the industry will really need to transition and kind of to change itself to really be able to keep pace with this change. So it's going to have to be a decision which comes probably from the OEMs. I know that Ford and I think Toyota have made recent commitments to continue ICE production at facilities within South Africa. But whether that will continue, say, in 4 to 5 years' time with new production commitments being placed into markets where you see sales volumes overall being reduced, I think there will need to be that continued transition to EVs. And we see at least mention from the South African government that there's likely to be further incentives to support the domestic market for sales of EVs as well, which is going to be critical to kind of allow that transition.
Thanks for that. Are there any other questions or comments or discussion?
Jock, you had your hand up for a bit. Okay, no. Craig, there's a question from Tinas in the chat.
Is there any lithium recovery from used batteries in South Africa at the moment? And in fact, that goes to a wider issue, which I've been thinking about, battery recycling in general. Are any of these technologies more amenable to recycling of battery components than others? And liable to win out, therefore, in some sort of consolidation process that might go on in the next 2 decades?
Looking at the recyclability of different lithium-ion technologies, and particularly those targeting recycling of the cathode materials, there continues to be challenges with recycling of lithium-ion batteries because of the wide variety of chemistries, the cell designs, and also the cost of unpacking electric vehicle battery packs as well. Now, there's a lot of commitments which have been made to increase the amount of lithium-ion battery recycling, and this also feeds into the kind of sustainability of lithium-ion production, which I'm sure Don can kind of touch on a bit afterwards. But when you're looking at the different technologies, there are advantages to each one, particularly the cost or the recoverable value of say, high nickel or NCM and NCA type cathode materials is much greater than, say, LFP, because of the nickel and the cobalt having a higher selling price. But that's almost been a bit of a restricting factor when it's come to recycling in previous years, as methods which have kind of lost the lithium during the recovery of nickel and cobalt have been used. What we're seeing now is a greater transition towards hydrometallurgical processing of battery when they reach their end of life, to recover the full suite of elements which are being consumed within that. And there's a huge amount of capacity which is under construction or development within, say, the Asian market, and now increasingly in North America and Europe, which is being constructed to really form a closed loop environment for automotives. And that's a real key target which many of the OEMs are factored into their longer term plans, is that they need that circular market for the material to come back through into the supply chain and then improve their sustainability, but also to alleviate some of the raw material supply concerns, which are undoubtedly going to form over the coming decades.
Yeah, I think touching on sustainability there, in the specifically in the kind of South Africa and Africa as a whole, when it comes to the battery supply chain, a lot of the issues that face many sort of African nations are predominantly social or governance in nature, of the ESG. When it comes to environmental concerns, specifically CO2 emissions, we actually find that, depending on the industry, many African nations actually fare quite favorably. But the issue comes from being locked into supply chains quite far afield. So, for example, if you look at the raw material supply chain for the EV sector that does exist at the moment, it's tied chiefly to Chinese refining capacity, which heightens its CO2 emissions in total. So the CO2 emissions for the raw material production, for example, are typically quite low, and then once it's shipped out of Africa, wherever that may be, it typically increases and inflates quite significantly because of that reliance on Chinese capacity. As Dave sort of talked about earlier, when you look at something like the cobalt sector with its production of intermediate cobalt products such as cobalt hydroxide, this favors the industry quite heavily, but it is still tied to Chinese refining capacity, and the industry kind of finds itself sort of hemmed in by its own supply chains in a lot of ways. And this is actually something that we don't just see specifically in Africa, but also in quite a few industries worldwide. And they're sort of hemmed in by their own supply chains and unable to significantly alter or reduce their CO2 emissions intensity overall. And that's not even touching on things like waste production, which would be much more of a factor when it comes to lithium-ion battery recycling. But yeah, as I said, the sort of chief concerns in the sustainability landscape right now within Africa, and ones that sort of give downstream investors pause, and it may even be more of a perceptions issue as opposed to a real issue, is the social and governance side, concern over working conditions, artisanal mining, specifically in cobalt, for example. So getting over that will be something that which will need to be achieved to develop any kind of downstream refining or downstream OEM manufacturing capacity in the next decade or so.
Are there any other questions or discussions, comments? It appears not. David and Igor and Dominic, thank you very much for contributing to this today. I think it's been a fascinating talk. And one of the things that's come out for me, compared to introduction of internal combustion engines in the early 20th century, is that the miners and explorers in particular need to do a pretty thorough risk analysis in terms of consolidation of technologies. I just have a hard time believing that 25 years from now, we're going to see the same number of technologies in vehicle construction, the battery industry, the manufacturing part of the equation, the recharging infrastructure, or the recycling potential and capabilities. It just seems to me that there's a lot more complexity, and you have to take a stand on how much consolidation is going to take place. I would assume that many of these technologies have to operate at scale to be commercially viable. So the miners, who go into sort of 10-year advanced projects to get a mine into production, need to take this stuff into account. And that suggests to me that the risk analysis becomes more and more crucial. So the information that companies like Roskill provide are going to be probably a little more crucial than they were when automobiles first took to the roads in the early 20th century. That's just my take on it.
Yeah, I would say I agree. It's still a rapidly changing market, and you need to kind of understand what the risk factors are further down the road, and we look to provide that in our coverage.
Well, thank you very much for that. With that, I'll close the meeting. I'll leave it open for a few minutes just in case there's any more discussion. But thank you very much for this. We will have this up on the GSSA YouTube channel. Apologies for me. I didn't record some of the first slide, but I finally did get the button pushed. So it will be available for viewing, public viewing at a later stage. Thank you very much.
Just one comment, there'll be another Roskill talk in 2 months, so hopefully you all join us. And it will be, who will be talking then? John Barnes will be talking in 2 months' time. So it will be Friday, the 24th of September.